Welcome back. So, last lesson we looked at stationary points and what they are, an introduction to them. We looked at the fact that they were tangent lines that had a gradient of 0. And there were three types. We had the minimum, the maximum, and then we had the inflection stationary point. What we're going to be looking at today is we're going to be looking at how we algebraically find these stationary points, because the majority of the time when you're looking for stationary points, you're going to have to use algebra to work that through. Very similar to what we did with in terms of increasing and decreasing, except we don't talk about the intervals when it's increasing or decreasing. We just talk about what the classifications of the stationary points are. So we're going to look at a couple of examples here today. Let's just get straight into it. So whenever we are finding a stationary point, we've got to find the derivative of that function and then equate it to 0. So if we look at this first one here, this first function, let's find the derivative of that function. So we've got 3x squared minus 6x minus 24. Now, in this question here, I've got my derivative, but I have to equate it to 0. You could use your graphics calculator to work this out, but let's use algebra because it's important to understand how it works and why it works. So, if I wanted to equate this to 0, I want to try and factorize this out. So I could divide everything by 3. So I bring the 3 out, I get x squared minus 2x minus 8. I can now equate that to 0. Now I'm ready to be able to find out my two functions. But one thing you want to think about here is, you want to be able to try and visualize what or how many stationary points you should be expecting or could have. We've got a cubic here, so if we're looking at the cubic, and I don't know what this cubic looks like particularly, but I do have a rough idea that it may look like this. If I know that the idea looks like this, I know that I'm going to expect at least 2 stationary points, at least, okay? So, and that should be what I'm looking for at the end. So when I differentiate this, I do end up getting something where I've got 2x values. So I know I'm on the right track at this point. So remember, whenever we're working with this math, that back thinking. We can find this out by using the null factor law. So what two numbers do I know that multiply to give me -8 and add to give -2? Well, the two numbers I can think of would be -4 and +2. So -4 times 2 is -8, -4 plus 2 is -2. So we can now therefore say that x has to be either 4 or x has to be -2. And what we've got here are what we call your critical points. They're your critical points because they're the points that are going to be showing the x coordinates on where your stationary points may lie. Okay? However, we need to use a way of showing that these actually are going to give me stationary points and what type of stationary points they are. And that's where the sign diagram comes into play. So if we drew our sign diagram up here, we're going to plug in our critical points. We've got x equals -2 and x equals 4. So what we need to do here is we need to work out, well, how is this graph looking when it's before -2? What does it look like between -2 and 4? And then what does it look like after 4? So we're going to take a number that's less than -2, a number between -2 and 4, and a number greater than. So we might say, well, let's plug in -1 here, or actually, we'll do -5, 0, and then plug in maybe 5 here. All we're looking for is checking out, well, is the answer going to be positive or negative in terms of when I plug this -5 into the derivative? Alright? So, when we plug -5 into this derivative, we can plug it into this point here. We get -5 minus 4 is -9. -5 plus 2 is -3, so -3 times -9 is going to give me a positive value. So I can say that before negative 2, it's positive. We then can have a look at this next one. What's it going to be between negative 2 and 4? We can put a 0 in there. So we can come straight back up here and say, well, we have 0 take away 4 and 0 plus 2. So negative 4 times 2 gives me a negative. So I know that between negative 2 and 4, it is a negative. Well, it's decreasing. And then after 4, we put 5 in again. This gives me 1, this gives me 3. This here is a positive function. So we can tell from our sign diagram that we have a graph that kind of looks like this. A maximum and then a minimum. Okay? So we're increasing, we get to a point, which is negative 2, we then start decreasing. We continue to decrease until we get to a point which is 4, and then we start increasing again because of these plus minuses. So indeed we found out that we do have 2 stationary points. Well, we know what the x coordinates are going to be. So if I wanted to find these points and classify them, I know that I have x is negative 2, and I also have that x could be 4. So I'm going to plug these back into my original function. Now just to save a little bit of time, well, we write them out. So you'll have negative 2 cubed minus 3, negative 2 squared. And then the same thing here, 4 cubed minus 3, 4 squared. And we get our answers in each case. So in each case here, I know that I should get 58 here and 50. So therefore, we can now classify what these stationary points are. We can say that we have a stationary point or a maximum stationary point at negative 2, 58, which makes sense because I've got negative 2 of them above the y value, the x equals 0 value, and we also have a minimum stationary point at 4, negative 50. Okay, so therefore I know that this here is going to be a negative because it's down below this value. So this is how we classify. So we'll call this here classify. So when it's asking you to classify the stationary points, it's asking you to tell you, well, are they maximum or minimum, and where does that occur? This is finding what your y values are, your sign diagram which is used from your critical points, and we find your critical points by differentiating and equating to 0. So this here is how we algebraically solve these stationary point questions. Alright, let's have a look at the second example. So, second example. We now need to differentiate this function. So let's write it up here first. And notice that we've got a square root there. We need to get rid of that square root first. So we can rewrite this here as x minus x to a power of half. And now we can differentiate this function. So we get 1 minus half x to the negative half. Now, really good practice here to be able to write this back into its original form because it's going to make life a little bit easier for us when we solve for x. So we've got 1 minus 1 over 2 square root x. And this here is the gradient of this function. Now we've found the gradient, we now need to equate this to 0. So if we equate this to 0, and let's just write this up here, we need to make life a little bit easier for us. What do we notice here? I could times this here by 2 times root x, but I'm going to get 0. I don't need that. I want to get an x value that's going to tell me what's happening. So what I can do here is I'll notice that this here is a fraction. I could multiply this side here by 2 root x and 2 root x, because then I have a common denominator. If I do that, I now have I'll have 2 root x minus 1 all over 2 root x. And now I can equate that to 0. It allows me then to be able to have this root x there what I'm looking for. So if we equate that to 0, we'll bring this across. Therefore we'll get root 2 minus 1 is equal to 0. I bring my 1 across, is equal to 1, divide by 2. And then I'm going to square by both sides, because I need to get rid of this square root. So this here now becomes 1/4, because everything about this here, the square of 1/2 is 1/4. So I've found my critical point. I now need to check, well, is this going to give me a minimum or a maximum? So we bring into play our stationary sine graph. I know I've got 1/4 here. So again, I'm going to be choosing a number that's less than 1/4. We can say let's choose a 0, and a number that's greater than 1/4. However, I noticed something in here. I noticed that if I plug a 0 in here, I'm going to get an undefined function. So what I can write in this point is I'm going to say, well, under 0, I'm not going to get any answers, because if I plug a 0 or anything less than 0 in this equation, I'm going to get something undefined, because I can't find a square root of a negative number, and 0, something divided by 0, won't exist. So I need to be really careful here that I choose a number between 0 and 1/4. So we might say, well, let's choose 1/8 or 1/16, as long as it's something between those. If we plug that in there, we plug 1/8 into this equation, we should get, what do I get? You should get a negative answer. Plug it into your calculator. And then I choose a number that's greater than 1/4. Well, let's just do 1, plug it into the derivative again. I should get a positive. So now I can look at this and classify my stationary point. I know that it's decreasing until it gets here, and then it increases. So I have a minimum stationary point. I know what the x value is, I now have to find the y value. So we're going to find this part here into the original equation, so I'll get 1/4 plus the square root of 1/4. Now we know that the square root of 1/4 is going to be the opposite to what we had before, because the square root of x is equal to a minus, not plus, minus. We know that here the square root of x is equal to half, so therefore I'm going to get negative 1/4, because 1/4 take away a half gives me negative 1/4. So therefore, the minimum stationary points have coordinates of 1/4 and negative 1/4. So if I was going to sketch this graph, I could say that I've got a graph that kind of looks like this, where my stationary point sits here. So, how do we work with stationary points again? First thing we do is we differentiate the function. Once we differentiate the function, we want to be able to equate that function to 0, and that's going to give us the critical points that we're getting to find a possible stationary point. Once we get that critical point, we use that in your sign diagram to establish what type of stationary point we found, by classifying it as a minimum stationary point, maximum, or it could be an inflection stationary point. Once we've done that, we then write down what the coordinates are, and if it asks you to sketch it, you sketch it through by finding the x-intercepts, equating this to 0, and finding the y-intercepts by plugging x equals 0 in. Alright, that's stationary points. I hope you enjoy, have lots of fun.